So, for example, if a pendulum is rotating at its natural frequency, which is the normal motion. So, natural frequency is basically the original motion of this pendulum. What if you somehow withdraw some of its energy and you decrease the oscillations? You decrease the amplitude of these oscillations. That is known as damping. So this concept of damping basically इसकी जो Marxian definition it says that continuous loss of energy due to force in the opposite direction. Could be a friction force maybe. Yeah. So opposite direction of motion. So basically, damping causes the amplitude to further to get reduced. So reduced amplitude. Why? Because lesser energy now. So obviously, when an object would be rotating with less energy, its amplitude would also be lesser. It will be reaching a lesser higher point. Okay. So a graph for damping would look like something like this. Initially, the amplitude would be greater,
आहिस्ते आहिस्ते डिक्रीज कर जाएगा.
बट आहिस्ता आहिस्ता वो एम्पलीट्यूड कम होता जाएगा. एक टाइम पे आके वो शायद बिल्कुल जीरो ही हो जाए, बिल्कुल रुक जाए. ठीक है. So this is displacement against time graph, and this is basically known as an exponential envelope. ये an exponential envelope is basically covering which explains the exponential decrease in the amplitude. So the characteristics of this graph, number one, amplitude decreases exponentially. Number two, frequency remains constant. And it is a simple harmonic motion. Constant frequency is a characteristic of simple harmonic motion. Remember. So this constant frequency here in this graph will once again testify to the simple harmonic motion. Now, how can you introduce damping? How can you actually achieve damping? So, uske liye, let's look at, because we just talked about an opposite force, a force acting in the opposite direction. Friction. Friction is one of the forces that can oppose the motion. It can be introduced into the system, and the energy can be withdrawn. So, friction in the mechanical system will achieve damping. Number two, if you look at one of the applications of this, आपने अक्सर देखा होगा cars में जो springs होते हैं, जो shocks होते हैं, springs, what do they do? They avoid vibrations after a jump. So springs basically are damped by these shock absorbers. So one of the examples of dampings in real life is shock absorbers in cars, in car springs basically, to introduce damping over breakers and jumps. So this is an application. All right. Now there are three types of dampings. Looking at the types of damping here. First type of damping is light damping. The second type of damping is critical damping. And the third type of damping is heavy damping. All of these dampings are basically three different types of mechanisms to withdraw energy basically. In light damping, the oscillations stop gradually, all right? So you can say it is a gradual stop without oscillations. The object continues to oscillate and it gradually comes to a stop. The second type of damping, critically, is an immediate stop without oscillations. यानी एकदम से रुक जाना. Oscillations भी नहीं है, slow down का कोई process नहीं है. So it's an immediate stop without oscillations. And heavy damping is gradual stop again, but no oscillations. Gradual stop without oscillations. Let's look at these graphs here. The first one, gradual stop with oscillations. Yeah. Gradual stop with no, sorry, immediate stop with no oscillations. बिल्कुल नीचे आ गया. And then gradual stop without oscillations. ये gradual. ये वाला comparatively is steeper. This one, the second one. And the third graph is a little more slanting. Why? Because the stop is gradual, but there is no oscillation in this case. So oscillations में सिर्फ ये वाला graph आएगा. The first one, where you see a it's very similar to graph of sine equation. Okay. Okay. Any questions so far?
Do all the types of damping come like in SHM, like simple harmonic motion में सारी count होंगी?
देखो सिंपल हार्मोनिक मोशन तो डैम्पिंग से पहले की बात है, राइट? अब जब डैम्पिंग आ गई है और एक ऐसे केस में जहां पे देयर इज नो ऑसिलेशन एंड द ऑब्जेक्ट इज लेट्स से स्टॉपिंग विदाउट ऑसिलेशन, तो सिंपल हार्मोनिक मोशन तो सिर्फ ऑसिलेटरी मोशन था ना. जब ऑसिलेशन ही खत्म हो गई तो सिंपल हार्मोनिक मोशन तो नहीं रहा, राइट? ओके, so let's look at the a concept that's opposite to damping. It's called resonance. Resonance is basically an increase in amplitude now. Increase in amplitude. इसमें कुछ भी हो सकता है. आपने you're adding let's say additional force, you're trying to increase the frequency higher than the natural frequency of the object. That is resonance, right? So it is necessary, number one, दो conditions हैं for resonance. It must be a free oscillating system. And the second condition is that there has to be a force to further oscillate it, right? तो होता ये है कि जो additional force, or you could say the forcing frequency, when that matches the natural frequency, that is when resonance is achieved. So the exact definition is the driving frequency. So the additional frequency is known as a driving frequency. All right. So isme, let's write down the exact definition. The driving frequency matches the natural frequency. Amplitude grows dramatically. For example, look at this graph. Amplitude और यहाँ पे क्या हो रहा है, frequency. So let's say this was the natural frequency or applied frequency. ठीक है, यहाँ पे graph would look something like this. अगर इस point पे both of the frequencies match. So this blue line over here indicates the point where your driving frequency matches the natural frequency, right? So this is why maximum amplitude is achieved at that point. This is where resonance is happening. Any questions?
No.
Oh, acha. Um, रेजोनेंस को रिमूव कैसे करें उसके लिए डैम्पर्स इंट्रोड्यूस करते हैं. So you need to, if let's say you need to reduce the frequency, try to achieve damping somehow, okay, by withdrawing excess energy. So yeah, this is a way to get rid of resonance. So eh, let's draw the graph that shows both damping and resonance. इसको अगर आप देखो, where is the point of resonance here in this graph?
Uh, बिल्कुल peak पे. Yeah, at the peaks of
Okay.
all the graphs.
This is where resonance takes place. This is heavy damping. This is light damping. So the greater the damping, lesser the amplitude. If you look at this graph, because the amplitude decreases after the point of resonance, why? Because there is damping. And by looking at this graph, you can explain, you can tell what type of damping there is. All right. So, all right. I think that is pretty much it from damping and resonance. इसमें your question to conclusion, what will you let me know?
Yeah, like एक question था like school में we were doing it और उसमें सर ने बताया था कि that like जब amplitude like उसका like the frequency जब decrease करेगी जैसे heavy damping के अंदर तो the graph will move like downwards and a little bit to the left जैसे भी आपने draw किया it's
Frequency
like
नहीं
moving
decrease
towards the
करेगी,
left like उसकी
amplitude.
क्या reason है या वो क्यों like move left पे क्यों move कर रहा है
ग्राफ लेफ्ट पे क्यों
like
मूव कर रहा है?
for heavy damping the peak is a bit
Um,
to the left
नहीं, असल your voice is breaking a lot. मुझे यहाँ तक समझ आया है कि you're saying
compared
कि
to the
जब
light damping.
amplitude reduce हो रहा है तो you're asking कि ग्राफ लेफ्ट पे क्यों मूव हो रहा है? Uh, Hasan, can you repeat your question? Yes, can you hear me?
Can you like mark the axis like y-axis पे amplitude है right
Y पे amplitude है? Yeah,
and x पे frequency है driving frequency है right
yeah.
yeah, okay clear
Now
so I think last
the
point मैंने
question
book
that
में
you
पढ़ा
had.
था there were like uses of resonance
हाँ
तो वो
बिल्कुल.
question like class के अंदर था वो यही बोला था कि सर बात कर रहे थे कि हैवी डैम्पिंग जब फॉर एग्जांपल उन्होंने ड्रॉ की होगी अगर पास्ट पेपर के अंदर लाइट डैम्पिंग और अगर वो कहेंगे कि हैवी डैम्पिंग का ग्राफ ड्रॉ करें आपने बिल्कुल पीक उसके नीचे नहीं बनानी लाइक यू हैव टू ड्रॉ इट अ लिटिल बिट टू द लेफ्ट लाइक जैसे ये लाइन लाइक बिल्कुल टेढ़ी आ रही है यू डोंट हैव लाइक टू ड्रॉ इट स्ट्रेट लाइक उसकी क्या रीजन है
अच्छा, देखो जब हम डैम्पिंग की बात कर रहे हैं ना, देखो एक पॉइंट है यहाँ पे. फॉर इंस्टेंस आपकी,
हेलो
जी हसन, कैन यू हेयर मी?
yes I can hear you
There is a delay in the voice. हमने what we're trying to establish here is maybe this is the point somewhere over here where your natural frequency matches the driving frequency, right? तो जिस टाइम पे अब जब हम डैम्पिंग की बात करते हैं ना, हमने भी कहा है कि लाइट डैम्पिंग में क्या हो रहा है कि ऑसिलेशंस है लेकिन एक ग्रेजुअल स्टॉप है। सिमिलरली जो हेवी डैम्पिंग है, हेवी डैम्पिंग में ऑसिलेशंस नहीं है, स्टॉप आपका ग्रेजुअल है, तो विड्रॉल ऑफ एनर्जी जो है ये आपको पता होना चाहिए कि ये एक ही साथ तो एक को एग्जिस्ट नहीं करेगा। यानी यू कैन नॉट एक्सपेक्ट ए सिंगल ऑब्जेक्ट to experience light and heavy damping at the same time, right? The withdrawal of energy would obviously take place at different intervals. Do you get me? हसन, आपको मेरी आवाज आ रही है? Anyways, so I was explaining your question. See, the reason why the peaks do not coincide over here is number one, these three processes take place at different intervals. Number two, the resonant frequency becomes less at heavier damping, right? So जैसे ही damping heavy होगी, इसी तरह से this is why this line slightly moved towards the left side. The reason for this is that the resonant frequency becomes less at heavier damping. Or another reason for this is that as the damping increases, ये जो peak है, जो resonant peaks हैं, they becomes more broader.
I'm sorry sir, लेकिन आपकी आवाज फिर से बहुत ज्यादा कट रही है। I think like it's an internet issue.
I think so too. Okay. ठीक है। अच्छा, if the voice gets cut off again, just do let me know. So I was explaining your question. The reason why the peaks do not coincide is number one, the energy withdrawals they happen at different time intervals. Number two, resonant frequency at heavier damping becomes less. This is why you see there is a slight curve in this line of frequency as well. ठीक है, जो
Oh, right.
जब डैम्पिंग नहीं होगी तो उसकी फ्रीक्वेंसी ज्यादा होगी,
Yeah.
जब डैम्पिंग होगी तो रेजोनेंट फ्रीक्वेंसी आपकी कम हो जाएगी, एंड थिर्डली because of that these peaks also becomes broader as soon as the damping increases, right? So जितनी ज्यादा damping होगी, so you can say
Yes, clear.
resonance peaks become broad at heavier dampings. जैसे जैसे damping increase हो रही होगी, your resonant peaks would also become broader. So ये इसके reasons थे. All right. And resonance is used in quartz crystals for timing production of ultrasound. ये सारे इसके practical uses हैं. इसके अलावा अच्छा वैसे तो we are done with damping and oscillations, and we're also done with this topic वैसे तो what we need to do is we'll have to move to these questions. लेकिन before that, let me just uh, take you through a few definitions, if exact marking scheme definitions that you need to know. Number one, natural frequency. So how would you explain natural frequency now? Can you see my screen? No. Okay.
Yes, I can see the screen.
You can? Acha. Really? Because here I cannot. Acha, ठीक है, you can. All right, perfect. तो ये बताओ कि how would you explain natural frequency now?
I think like the when there's like no resistive force or एक body की जो natural vibration होती है, the frequency because of that, I think.
Yeah. So uh, it's a frequency at which the object vibrates when it's free to do so. All right.
No external resistive
Yeah,
force,
no
right?
external force. So free vibrations. Number two, how would you explain forced frequency?
I think like when force is required to cause the oscillation, right?
Yeah, perfect. So when the object is made to vibrate, ठीक है? Um, so whenever for these questions as well, because obviously you'll be doing questions now, acceleration, if it is not provided, take 9.81. ठीक है, इसका मतलब फ्री फॉल का केस चल रहा है. So
ठीक है.
9.81 is always to be used if there is no acceleration given in the question. Resonance question इस तरह का भी आता है कि where should resonance be avoided on bridges खास तौर पे, क्योंकि अगर bridges में resonance आ जाती है, जो force frequency, for example, if a heavy vehicle travels on a bridge, or if there is, let's say, march की example बहुत marking scheme में आती है, if there are people marching on a bridge, तो उससे क्या होता है, there are always forced vibrations, and when those forced vibrations, forced frequency is going to match with the natural frequency of the bridge, क्योंकि obviously जो objects हैं oscillate तो कर रहे होते हैं, तो फिर there are chances of collapsing, resonance वहाँ पे आ जाती है. So in these examples, in these you could say infrastructural जो कि uh, uh, pieces हैं, इनमें you'll obviously have to avoid resonance in any case. तो dampers हैं जो कि लगाए जाते हैं खास तौर पे in construction of bridges to avoid resonance. All right. You can also remember this example. You can write it down somewhere with you. You'll see a few questions in the marking scheme, or not the users, but places where you specifically need to avoid resonance. All right. All clear?
Yes, clear.
Okay.